All right, guys, good news. This is the last video of the unit. That's good news for you. That's good news for me. And that's good news for everybody. All right, so this last section is about trig applications and modeling. So in other words, everyone's favorite word problems. All right, so it says from a point 100 feet in front of a public library, the angles of elevation to the base of the flagpole and the top of the flagpole are 28 degrees and 39 degrees 45 minutes, respectively. The pole is mounted on the front of the library's roof. Find the height of the pole. So I'm going to have you guys try this one on your own. Okay, there's a couple ways you could solve this, but let's see what you guys can do on your own first. Obviously, as always, let's draw a picture first. If you're struggling to draw the picture, break down the problem. Read it slowly. All right, go ahead, put me on pause. Okay, so let's begin by just talking about the picture. So here's the library, can't you tell? And here's the flagpole on top of the library. You guys know what country this is? Anyway, so it tells you that the library, you're standing from a point 100 feet from the library. Okay, there's an angle of elevation. Remember, angle of elevation is start looking at the horizon but going up. So 28 degrees. And then if you're wondering where this 11 degrees 45 minutes came from, well, that's from taking the 39 degrees and 45 minutes and subtracting the 28 degrees. Is that super important? No, you didn't have to write that in there, but I just did for the sake of the picture. So there's actually a couple ways you could do this. Perhaps you used law of sines. I used a system of equations. Either one will get you to the right answer. So I said tangent of 28 degrees is height over 100. So I got that the height was 53.171 feet. Then I used the tangent of 39 degrees and 39.75 degrees. If you're wondering where the 0.75 came from, well, 45 minutes is 0.75 of a degree equals x plus h over 100. If I solve for x plus h, I get 83.19169. But I can plug in a value for h, sorry guys, and I get that x is 29.998 feet. But since this is a word problem, I want to make sure that we respond to what the question's asking. It says find the height of the pole. So in words, make sure you are getting in the habit of doing this. I say the height of the flagpole is 29.998 feet. Done. Next one. An engineer erects a 75-foot vertical cellular phone tower. Find the angle of depression from the top of the tower to a person standing on the ground 95 feet from the base of the tower. Very similar here. Make sure we draw a picture. And obviously, since this is called trig applications, probably use some trigonometry in solving this. Go ahead and put me on pause. Okay, so here's my picture. Here's the person. Let's call this Craig. Wow, Craig's a stick person. Here's Craig. He's standing 95 feet from the tower. And here's my angle of depression theta, which is what we're looking for. Now remember, an angle of depression is looking horizontally and then downward. Okay? And then this should hopefully bring back some geometry to your heads. These are alternate interior angles, which should be congruent, so we have parallel lines. So what I did is I said tangent of theta is 75 over 95. I could solve for theta, and I got about 38.290 degrees, which since these are alternate interior angles, so to answer the question, the angle of depression from top of the tower to the person on the ground 95 feet away is 39.290 degrees. Cool color combo, huh? Okay, next one. Two fire towers are 30 kilometers apart, Tower A being due west of Tower B. A fire is spotted from the towers, and the bearings from A and B are east 14 degrees north and west 34 degrees north, respectively. Find the distance D of the fire from the line segment AB. Okay, so I'm going to start by coming up with a drawing or diagram or figure for this. I think you should try your best to do that first, because if you just look at what I have, you're never going to really be dissecting what this says and thinking about how it could be drawn out. So do the same thing that I'm going to do. Draw a picture. I'll help you guys. You'll unpause me and check that we have the same diagram, and then we'll actually try to solve it. Okay? Go ahead and put me on pause. Okay, so again, we're just checking right now your diagram, seeing how that is. So it says 2 fire towers are 30 kilometers apart. Tower A being due west of Tower B. Due west just means straight to the west. So here's A and B. A is west of B. Due west, that is. Okay? It says a fire is spotted from the towers. Here's my fire, obviously. And the bearings from A and B are, so now we have to understand bearings. So from A and B, so from A, it's east 14 degrees north. So what does this mean? Let's highlight it to emphasize its importance. East 14 degrees north means go east and then 14 degrees north. Okay, so that's how I got that angle. And from B, go west and then 34 degrees north. So that's what those bearings mean. Now it says find the distance D of the fire from the line segment AB. So if I'm finding the distance from the fire to this line segment, obviously I'm finding the height of the altitude. Okay, so now let's have you guys go ahead. Now that we have this diagram set up, let's have you think of a creative way to solve for D. Okay, so go ahead, put me on pause, and then we'll check your work. Okay, so if you got this one right, hopefully you got that the distance from segment AB to the fire is 5.461 kilometers. How on earth did I get that, you're wondering? Well, let's take a look here. So once again, I did use a system of equations. Oops, sorry, I'm just kind of playing around. There we go. I did use a system of equations once again. So I said that the tangent of 14 degrees is d over 30 minus x, and I solved that for d. Let's just highlight that. Oops, okay. Then I said that the tangent of 34 degrees is d over x. I solved that for d. Since I have two things equaling d, I set them equal to each other. Right here. Stay. Good. I set them to each other. And ultimately, I have one variable in here, so I just want to solve for x. So I just did a bunch of algebra, basically. I distributed that, brought the term with x so that they're both on the same side. I factored out a GCF of x, divided. So I got that x was about 8.096 kilometers. Then I just resubstituted that into either one of my equations that were already solved for d, and I got that the distance was 5.461 kilometers. All right, next one. An airplane flying at 600 miles per hour has a bearing of north 52 degrees east. That means go north, then look, or then go 52 degrees east. After flying for 1.5 hours, how far north and how far east has the plane traveled from its point of departure? Go ahead and try this one. Okay, so we had an airplane that was flying 600 miles per hour. Here's my airplane. It looks more like, I don't know. It doesn't look like an airplane, but you get the point. It was flying at 600 miles per hour at a bearing of north 52 degrees east. So it was going north and then 52 degrees east. So here's where my plane has ended up. And the question was asking how far north and how far east has the plane traveled since its point of departure. So this 900 miles I get because it has traveled 1.5 miles, sorry, at 1.5 hours at 600 miles per hour. So it's traveled 900 miles total. So I'm solving for x and y. So I have two separate equations here. I said that the sine of 52 degrees is x over 900. So x here going east is 709.210 miles. And cosine of 52 is y over 900, so I got 554.095 miles. So to put it in word format is my answer. The plane has traveled I don't know why it does that. The plane has traveled 709.210 miles east and 554.095 miles north. Last one. All right, this one's going to be a doozy, but we can do it because we are smart. You leave the entrance to that's a system. Not really, but just think it does. You leave the entrance to a system of hiking trails and hike 2.3 miles on a bearing of south 31 degrees west. Then the trail turns 90 degrees clockwise. That's important. What's clockwise? And you hike 3.5 miles on a bearing of north 59 degrees west. How far are you from the entrance to the trail system? What is your bearing from the entrance to the trail system? So once again, let's work on setting up the diagram first. I'm going to do it. You're going to do it. We're both going to check. Well, really, you're just going to check. Then you'll pause me. You'll check. Then we'll actually try to solve it once we're for sure set on the diagram. So go ahead and put me on pause. Draw it out. Okay, so it's 1,000% possible and likely that your diagram doesn't look exactly like mine. But I'll just kind of explain what I was doing, and maybe you have something like mine, maybe you don't. So remember, the person's hiking. They are hiking 2.3 miles on a bearing of south 31 degrees. Then the trail turns clockwise, and they go for 3.5 miles on a bearing of north 59 degrees west. So I went clockwise, and I looked north, and then 59 degrees west. How far are you from the entrance to the trail system? So we're looking for X. And what's your bearing? So now that we have this set up, let's kind of understand it. So here's where we're starting. I use all kinds of different variables here. Maybe you guys can kind of tell what I'm going to be going for here. Maybe you can't. We'll see. But I just labeled these four sides. I know that Z plus W is R. I know that P plus Q is Y. And let's see if you guys can figure out why I set it up this way. Okay, go ahead and put me on pause. All right, this one was a bit of a doozy, but let's see how you did. So I started at first by figuring out what's the value of Y, what's the value of W, what's the value of Z, and what's the value of Q. Okay, so I did those things first. That's going to be helpful for us in finding P and also help me find R, okay, which relates directly to the triangle related to theta and X. So I found that the cosine of 31 degrees is y over 2.3, so y is 1.971. I did the same thing with W, except it was a sine. I did that here to find Z, and then here to find Q. All right. Next, taking over here, well, we knew that P was really just y minus Q, so I found that P was 0.168, and I found that R was really Z plus W, which is going to be 4.185. So just to really help us here, let me write this in my picture. So R is 4.185. P right here is 0.168. Okay. Remember, we want to know what theta is, and we also want to know X. So now this should look familiar, something we can do. To find X, I used Pythagorean theorem, and I got that X is 4.188 miles. To find theta, I had to use the inverse tangent, and I got 2.299 degrees. So to put it as my final answer here, I said, you are 4.188 miles from the entrance at a bearing of west, 2.299 degrees south from the entrance to the trail system. Okay. Maybe go over the work one more time if that didn't make sense to you. Thank you guys for listening.